I'm here with you next topic, and what this topic is, probably you do know. And in case you follow your NCERT, the next reaction after the carbylamine reaction is Hinsberg's test. So what this Hinsberg's reagent or Hinsberg's test is, this is what I'll be talking today. But before I do that, I want you to introduce to the motive of this reaction. In the carbylamine reaction, you differentiated 1 degree amine from 2 degree and 3 degree, where 1 degree amine was able to react with the chloroform in presence of basic medium, and it produced a false smelling compound isocyanide. But we didn't talk about how we can differentiate 2 degree amine from the 3 degree amine. So now this is what the question is that actually brings you to this particular topic called Hinsberg's test, right? Because this test is way more effective than carbylamine test. Why? Because you can differentiate all 3 types of amines, 1 degree, 2 degree and even 3 degree. Because the reaction is going to be in a different way, right? So what I'm doing right now, I'm doing a short method here, and then I'll describe the mechanism, but not right now, right? So I'm describing Hinsberg's test in a very, very short method. Hopefully I will make it too, right? So let's see what this Hinsberg's test is. Now, in order to get through that, we have to started with first one, and the first one is is a primary amine. So let's concentrate here. This is your primary amine, RC, or just RNH2 would be enough. RNH2. Now, if you react this 1 degree amine with aryl sulfonyl chloride, aryl sulfonyl, what this aryl sulfonyl is, this is what it is, aryl sulfonyl chloride. Then what you come across is that one of the hydrogen that is present here with the nitrogen is in a situation where this can come out and form HCl when the bond between H and Cl. So since it's going to be a short one, so let me do this very quick. So what will happen? This bond will undergo cleavage, and this will form a negative ion, while this bond will break to form a positive ion. So there you have your byproduct, and that's going to be HCl. So HCl is your byproduct. Now what you need to do? You need to attach the remaining part together. Right? So what you have now, you have R, you have N, but has an H here, and with that you have sulfur, along with that you have double bond O, another double bond O, and finally you have the aryl group. So this is the reaction, with the 1 degree amine, right? Now let's see what the 2 degree amine, the reaction, takes place to be. So I'm taking you through the 2 degree amine. This is, your 2 degree amine, where, there is only one hydrogen here, and you have to use another alkyl group here. Now, when this one react with aryl sulfonyl chloride, now, you probably have started understanding that this reagent is called Hinsberg's reagent. This is called Hinsberg's reagent. What is that name? Aryl sulfonyl chloride. So this is your aryl sulfonyl chloride. Now let's concentrate here. Again, what will happen? This chlorine will come out as a negative charge, and this hydrogen will come out as a positive charge. So this will be again the reaction is taking place, and it produces HCl, and along with that it produces also you have your R, you have N, but N is now bonded to sulfonyl group, S double bond O, S double bond O, and then you have aryl group here, and along with that you have no hydrogen left, right? Am I sure here? Let me check out. So you have Ar, that's okay, you have chlorine gone, you have hydrogen gone. So this is what happened. Yeah, there was a alkyl group here. So this is the product of the 2 degree amine. Now let's see what is this 3rd degree amine is about. So this is your third one. Now what you have to do, you have to take a 3 degree amine. So this is what your 3 degree amine is. I'm not changing the R here, I'm just taking the same. So when this one react with aryl sulfonyl chloride, aryl sulfonyl, what sulfonyl is? Again sulfur double bond oxygen and there is a chlorine. So what will happen? Now you can easily estimate here. The compound formed here, just concentrate. The compound formed here is it's something different here. But when you compare this one with the secondary, this is something else coming out to be. This is going to be something else. I'm coming to that, but let me finish this one. What will happen here? Since there is no acidic proton, and since there is no acidic proton, and therefore there will be no reaction taking place. So what you see, that 1 degree, 2 degree and 3 degree amines are reacting in an absolutely different manner with the Hinsberg reagent, right? Where the third one, where the tertiary one doesn't even react with, right? This is what the difference is. Now let me come back to 1 degree and 2 degree. See, the situation is here, this compound formed, in the first case, what happened when this one, is dissolved in a basic solution like KOH. This one is in a basic solution. What happened? This one dissolved. This one dissolved. But this compound in KOH, doesn't dissolve. Let me write this. This one does not dissolve. So this one remain as a PPT. But here there is no product coming out to be. So this is how you can differentiate in a very simple and short way 1 degree, 2 degree and 3 degree amines when you react with the Hinsberg reagent. And what that Hinsberg reagent is? Aryl sulfonyl chloride, right? So the 3 types of amines gives a very different reaction with this Hinsberg reagent. So this is way more useful than the carbylamine test actually. So let's concentrate and see over here what I have done. So in case you have understand what this whole process is about, you might be able to differentiate. So if there is a question in your exam, give distinction for 1 degree, 2 degree and 3 degree amine, this test going to be most useful, and it's even better than the carbylamine, because carbylamine only differentiate 1 degree from 2 and 3 both, but this test differentiate all 3 in a different way, because the products in these 3 cases are coming out to be different. In fact, in the tertiary one there is no product coming out. So this was your short method to describe this Hinsberg test. I would say I have to wrap up this right here, and see you in the detailed mechanism of this very reaction in the next lecture. Take care.